Hey, welcome back. All right, last section of our chapter. So, here we go. Multiple step algebra equations. We're going to start off with a two-step equation. Let's see if I can help you guys out. So notice I've got 8f plus 3 equals 19. So my goal is to figure out what is the variable, what is the number I don't know. In some of the other problems, when it's only a one-step equation, it's fairly intuitive to know how to be able to just guess what this number is going to be. However, when you get into two steps and beyond two-step equations, you may find that it's not as intuitive, and that's why you have to know your steps. You have to know how to isolate your variable because you're not going to be able to just figure it out in your head. Let me show you what the picture of this looks like. Notice I have 8 f's plus I have 3 added on. And how much does this whole thing equal? It equals 19. Think about it. How am I going to isolate the variable, man? I've got two things here. Well, the first thing I like to realize is that if I get rid of what's being added on first, I can get one step closer to getting the variable by itself. So, notice, real quickly, I'm just going to change 19 into 16 plus 3. And if I take away the 3 here and I take away the 3 there, I hope you notice that all I have left is 8f plus equals 16. And now isn't it just a one-step algebra problem, much like we did last section? So that's going to be the key. We always get rid of what's being added on first, because now notice our variables are isolated. How am I going to get all the f's even more isolated? Well, just cut it into 8 pieces, because each of these pieces is one f. Heck, they're all f's. Can you count all 8 of them? And what's going to be down here? Well, heck, each piece is going to be a 2. They're all going to be 2, because all those 2's add up to the 16. So if I divided the 8 f's into 8 different pieces, I ended up getting 1 f. And if I divided 16 into 8 pieces, I got 2's. Each f equals a 2. And that's our answer. All right, let's check out the rules. When equations require both the addition and multiplication division properties, we always use the addition property first. We always undo what's being added on first. So in this problem, I undid the addition first. Then I used the division property to undo the multiplication. And I got my answer. If I wanted to check to see if I was right, all I have to do is plug the 2 back in to the original equation, and what do you know? 19 equals 19. All right. So we're going to be using a 2-column proof here because I want everyone to know which rules come first. So notice I'm doing this problem because it was given to me. I used the addition property of equality to add -3 to both sides. And then I used the division property in order to isolate my answer. All right, you try. I'm going to leave this up so that you can see the example up above you, and then we'll go on to the next problem in just a second. All right, here we go. Did you undo what was being added on first? Did you use your division property? Did you remember a positive divided by negative is negative? Do you notice that I did the exact same steps in the exact same order? You guys try this one. All right, here we go. Notice I turned every subtraction problem into an addition problem. That's called the inverse property, in case you wanted to write it down. Now, did you undo what was being added on first? Do you notice how I undid the -7 because the -7 is being added on to this variable piece? So I added 7 to both sides, and then I divided by negatively. Negative divided by negative is positive, and I end up getting my answer. All right, that's how you do a 2-column proof. We're going to practice this lots, and if you've got questions, please feel free to email me. Have a great day, everybody.